Our planet is a blue planet.
Oceans cover most of Earth's surface.
We know more about the moon than our oceans.
The deep sea holds countless secrets.
It teems with strange and wonderful life forms.
Join us as we uncover the mysteries beneath.
Each ocean zone supports unique life forms.
The surface layer is rich with marine life.
Deeper it becomes darker and colder.
Yet life thrives even in extreme conditions.
The deep sea is a vibrant ecosystem.
It is a treasure trove of biodiversity.
Understanding it helps us understand our planet. The top layer of the ocean, called the sunlight zone or epipelagic zone, is bathed in sunlight.
This zone extends from the surface down to about 200 meters or 650 feet.
Here, sunlight fuels photosynthesis, the process by which plants and algae convert light energy into chemical energy.
Tiny plants called phytoplankton are the primary producers in this zone, forming the base of the ocean's food web.
Phytoplankton are like the ocean's grass, providing food for a vast array of marine animals.
Small fish and zooplankton graze on phytoplankton.
And these in turn are eaten by larger predators like tuna, sharks, and whales.
The sunlight zone is also home to coral reefs, vibrant ecosystems that provide shelter and food for countless species.
As we descend deeper into the sunlight zone, the amount of light available for photosynthesis decreases.
This region, known as the dysphotic zone, is characterized by a twilight-like environment.
Many animals in this zone have developed adaptations to survive in low light conditions, such as large eyes or bioluminescent capabilities.
Below the sunlit surface, the ocean plunges into a realm of perpetual twilight.
This zone, known as the mesopelagic or twilight zone, extends from 200 meters or 650 feet to 1,000 meters or 3,300 feet.
Here, sunlight fades with increasing depth, creating a world of shadows and shimmering light.
Many creatures in the twilight zone have evolved the remarkable ability to produce their own light through a process called bioluminescence.
This light can be used for a variety of purposes, including attracting prey, communicating with other animals,
and camouflaging themselves from predators.
One of the most iconic inhabitants of the twilight zone is the giant squid, a creature of myth and legend.
These elusive animals can grow to enormous sizes, with some estimates suggesting they can reach lengths of over 60 feet.
The twilight zone is also home to a variety of other fascinating creatures, including jellyfish,
Crustaceans and fish.
Many of these animals undertake daily vertical migrations, moving up to shallower waters at night to feed and returning to the depths during the day.
Beyond the reach of sunlight lies the midnight zone, also known as the bathypelagic zone.
Extending from 1,000 meters or 3,300 feet to 4,000 meters or 13,100 feet, this region is shrouded in perpetual darkness.
Here, the water is extremely cold and the pressure is immense, over 1,000 times greater than at the surface.
Despite the extreme conditions, the midnight zone is teeming with life.
Animals in this zone have adapted to survive in the absence of sunlight and the scarcity of food.
Many are bioluminescent, using their light to attract mates, lure prey, or startle predators.
One of the most striking adaptations found in the midnight zone is the development of large, sensitive eyes.
Animals like the vampire squid, with its enormous blue eyes, rely on their vision to navigate the darkness and detect the faintest glimmer of bioluminescence.
The midnight zone is also home to a variety of bizarre and wonderful creatures,
including the anglerfish, with its bioluminescent lure.
The gulper eel, with its enormous mouth that can swallow prey larger than itself.
And the tripod fish, which uses its elongated fins to perch on the seabed.
Section 5, the Abyssal Plain, a Seabed of Wonders.
Below the midnight zone lies the abyssal plain, a vast expanse of seabed that covers much of the ocean floor.
Extending from 4,000 meters, or 13,100 feet, to 6,000 meters, or 19,700 feet. This region is characterized by its flat, featureless terrain and its extremely cold and stable temperatures.
The abyssal plain may seem like a desolate wasteland, but it is far from lifeless.
A surprising diversity of creatures call this region home, including sea cucumbers,
Sea stars, brittle stars, and worms.
These animals feed on the rain of organic matter that drifts down from the surface waters, known as marine snow.
One of the most remarkable features of the abyssal plain is the presence of manganese nodules.
potato-sized concretions of metal oxides that litter the seabed.
These nodules, which form over millions of years, are rich in valuable metals such as manganese, nickel, and copper.
The abyssal plain is also home to a variety of deep-sea corals,
which, unlike their shallow water counterparts, do not rely on sunlight for survival.
These corals obtain their food by filtering organic matter from the water column
and provide habitat for a variety of other deep-sea creatures.
Section 6. Hydrothermal vents, oases of life in the deep.
In the depths of the ocean, where sunlight never reaches, scientists have discovered a remarkable ecosystem that thrives not on photosynthesis, but on chemosynthesis.
This process, which takes place at hydrothermal vents, uses energy from chemical reactions to produce food.
Hydrothermal vents are fissures in the ocean floor where seawater seeps into the Earth's crust, is heated by magma, and then spews back out into the ocean, carrying with it dissolved minerals and gases.
These hot, mineral-rich fluids support a unique community of organisms that have adapted to survive in these extreme conditions.
At the base of the hydrothermal vent food web are chemosynthetic bacteria, which use energy from the oxidation of hydrogen sulfide, a gas released from the vents, to produce organic compounds.
These bacteria form the basis of a complex food web that includes giant tube worms, clams, mussels, crabs, and shrimp.
The discovery of hydrothermal vents revolutionized our understanding of life on Earth.
It showed that life can thrive in the absence of sunlight, relying instead on chemical energy.
This discovery has implications for the search for life on other planets, as it suggests that life could exist in environments that were once thought to be uninhabitable.
Section 7. The Hadal Zone, the deepest trenches.
The deepest parts of the ocean, known as the Hadal Zone, lie in trenches that plunge to depths of over 6,000 meters, or 19,700 feet.
These trenches, formed where tectonic plates collide, are home to the most extreme conditions on Earth, with crushing pressures, frigid temperatures, and perpetual darkness.
Despite the challenges, life persists in the Hadal Zone.
Scientists have discovered a surprising diversity of creatures living in these extreme environments, including fish, amphipods, and sea cucumbers.
These animals have evolved unique adaptations to survive the crushing pressure, such as flexible skeletons and bodies that are less dense than seawater.
One of the most iconic inhabitants of the Hadal Zone is the giant amphipod, a crustacean that can grow to over a foot in length.
These scavengers, which resemble oversized pillbugs, play a vital role in the deep-sea food web, consuming dead animals that sink to the ocean floor.
The deepest point on Earth, located in the Mariana Trench, is known as Challenger Deep.
This abyssal chasm plunges to a depth of almost 11,000 meters or 36,000 feet, a place of unimaginable pressure and darkness.
Yet even here, life finds a way.
Section 8. Adaptations to extreme conditions.
The deep sea presents a unique set of challenges for life to overcome.
The absence of sunlight, the crushing pressure, the frigid temperatures, and the scarcity of food have all driven the evolution of remarkable adaptations in deep-sea creatures.
Many deep-sea animals have evolved bioluminescence, the ability to produce their own light.
This light can be used for a variety of purposes, including attracting prey, communicating with mates, and deterring predators.
For example, the anglerfish uses a bioluminescent lure to attract prey in the darkness.
To withstand the crushing pressure of the deep sea, many animals have evolved flexible skeletons and bodies that are less dense than seawater.
Some fish, like the deep-sea hatchetfish, have even evolved collapsible lungs that allow them to change their buoyancy and move up and down in the water column.
The scarcity of food in the deep sea has led to the evolution of a variety of feeding strategies.
Some animals, like the gulper eel, have enormous mouths and expandable stomachs that allow them to swallow prey larger than themselves.
Others, like the tripod fish, have long, sensitive fins that they use to detect prey on the seabed.
Section 9. Exploring the unknown, new discoveries and the future. The deep sea is one of the last great frontiers on Earth.
Despite advances in technology, much of this vast and mysterious realm remains unexplored. New discoveries reveal the incredible diversity and resilience of life in the deep.
Scientists use submersibles, ROVs, and autonomous underwater vehicles to explore. These technologies allow us to observe deep-sea creatures and collect samples.
Recent discoveries include new species of fish, corals, and crustaceans. The deep sea plays a vital role in regulating Earth's climate. The ocean absorbs vast amounts of carbon dioxide. Deep-sea organisms are key in this process. Exploring the deep sea helps us understand and protect this vital ecosystem. By understanding the deep sea, we can better manage our impact on the ocean, ensuring the health of our planet for generations to come.